Welcome to the Harvesting Wisdom podcast. Together we explore the vast landscapes of life, delving into the rich soil of experiences, sowing the seeds of curiosity, and harvesting the profound wisdom that each episode unfolds. Welcome to another podcast of Harvesting Wisdom. I'm your host, Mike McMahon. Today, we are in Tennessee, Knoxville, Tennessee, outside of Knoxville, Tennessee. And then we'll talk about some of the other players and talk about Hiwassee.
Yeah, well, I am one of the two co-founders of Hiwassee Products.
Okay.
So a little background, everybody working on the Hiwassee team, we're all members of the same church group.
Okay.
So we purchased and co-owned the Hiwassee College campus, kept the name, so now it's the Hiwassee community, and then chose the name for our enterprise.
Mm-hmm.
We have a background in manufacturing. We run other manufacturing enterprises as well. So that's kind of the expertise that we're bringing into this whole field, rather than coming in from a strongly agricultural background or even a specifically soil health background. We've learned a lot of those things as we've been in this space. So with the new location in a new state in Tennessee, we were kind of thinking about how do we support ourselves financially. Wanted to do something manufacturing, and really quite a few of us have been very inspired by the whole field of regenerative agriculture, agricultural sustainability, soil health. So really thought about, for one thing, there's this emerging market. They're going to need tools to implement, the new practices that are being developed. But beyond that, it's just a super inspirational field to be in.
Right.
I love every interaction with everybody who's in this space. Very forward-thinking, very caring about so many different things. So that's sort of how we landed on, okay, we want to produce equipment that will benefit the whole field of soil health, of regenerative ag. So then we started looking around and, okay, what is it that farmers are going to need? What are the barriers to adoption for implementing the different, the soil health principles and so on? At the same time, we have another location in New York. They were working on implementing a lot of these practices in their own food production. So they had some fairly poor soils that they were trying to grow vegetables in, and we're looking to the whole area of soil biology to improve the biology in the soil to kind of improve food production within that soil. So then they were working with people who were trained by Dr. Lane Ingham in the soil food web, who were producing vermicompost, compost extracts, and applying all of that. And, as they got to know Todd Harrington up in Connecticut and the tools that he was using and so on, this became an opportunity then. Here's something that's not really being done at scale. The tools that are being used are not commercialized. So that's kind of how we landed on working on compost extract specifically.
Yeah. And it's a cool niche because I've been in, I guess, agriculture most of my life in one form or another. And we, with our nonprofit urban farming, we're in schools. We have a school platform, preschool to senior level in high school, but everything we're doing is more do-it-yourself, compost bins and vermicompost rows, and maybe the school has a microscope or we have a microscope that they use, but it's been hit or miss. And we're walking through your facility and we're looking at your products. They're priced extremely well, in my mind, because a school or a school system can get a full product range. We talked about it being a system, and the idea of going to liquids is, crucial as well, because you can get so much more done. But we're really talking biology, mostly is what we're working with, and so it's phenomenal setup for any school to have, from a standpoint of you're working with the compost and then you're creating worm compost and vermicompost, then you're actually extracting it. You've got a lab that you can check it out. It's so tangible for students it's so hands-on for students, and they can get it. And so what turns off a lot of kids in school, and I think for me when I was in school, was all the Latin names and, the understanding of how a lot of science is based on a certain amount of nomenclature and a method of classifications, right? So that actually is easier to learn to me once I understand the basics.
Mm-hmm.
Like, what are we trying to do? What's actually going on? So really, you got the ability to show the foundations of life with these microbes and what you're doing, and the kids can tangibly see how it's going to improve the stuff they're growing, right? So, but let's talk a little about this. You talked about it in New York. It kind of came from a need to grow better food.
Yes.
And a need to work with the soil that might have been depleted. And I know that part of New York. It's woodlands. And a lot of early settlers to the United States had clear woodlands. And it wasn't necessarily, when they did that, it wasn't the best soil. I actually read a book by a farmer from England that was brought in by Thomas Jefferson, George Washington, to assess the state of agriculture in the U.S. And at that point, the guy was a little dismayed, and he didn't think there was much hope, even though then we became the largest agriculture in the world, right? But the idea that was born, and then you took over the mechanical portion, which was, to me, a missing link. It was really a missing niche.
Yep.
And the fact that you came up with something, and it's almost parallels everything we're trying to do with urban farming. It's the perfect complement, and it's perfect for schools. So, but I see this campus here, it's almost 500 acres, and the school used to have horses and the cows and farm plots and stuff. So I don't know if you have the farmer here yet, or the farmers here yet that will become part of this, but you have the ability right here to show how a circular system works, right?
Yeah, certainly. And I think going back to the education component, the whole world is kind of starting to learn more and more about this in real time. You had, Dr. Lane Ingham and others, even as recently as the 90s, beginning to crack the code on, okay, what are all these microbes doing in the soil? What makes good soil, poor soil? We use the term soil health, right? Health, you wouldn't use the term health to describe, gravel or sand or soil, silt and clay. Inorganic material. Health refers to a living organism or a living ecosystem.
Right.
And so to really understand the soil as an ecosystem, once you begin to understand that, now you can start looking at the different applications in different forms of agriculture. So, you have Alan Savory, who trialed the rotational grazing methodology. That's being widely adopted.
Which could be on this campus.
Yeah, absolutely. Well, we're starting to implement that.
Yeah. Yeah, you talked about some of those pioneers. It was E.O. Wilson and Clive Edwards and Rhonda Sherman from North Carolina State,
yes,
and Dr. Ingram, all really our current heroes or pioneers. Clive Edwards and I think E.O. Wilson have passed away, but certainly recent in the last few decades have really given us a better idea. Now the question is how do we get it to the average person? Because the world has gone urban, right? So 80% of populations now are living in urban areas, and because of it, we lost touch with the ground and the soil and the understanding that soil health. Why is it important to you for soil health, for instance? From a standpoint of, who cares if the soil's healthy or not?
I would say, so backing up a little bit, when I first began to learn about regenerative ag in around 2017, 2018, it was quite a paradigm shift for me to realize look at the various problems, environmental issues. I'm an outdoorsman. I'm a bird watcher. I love the environment. Right. I want to raise my kids where they can go out and observe nature and be in touch with nature. That's one component of it. And then human health, just the understanding that I can actually make and did make myself healthier by focusing on more naturally grown food products, less processed and so on. So there's the human health component, the environmental component, and then what really blew my mind was the economic component, that when you start farming with nature, you can start subtracting a lot of the synthetic crutches and end up being more profitable in the long run.
Sure.
So the fact that all of those three things combined, into a win-win-win solution was just mind-blowing. So I think I look at this very much from a solutions point. And, with the soil in specific, that's where everything living grows from,
Right.
going up through plants and then insects, birds, etc. But the ability to improve, our environment, to improve our health, to improve the economic viability of small stakeholders, including farmers who have a really rough go right now. Why wouldn't you want to be focused on that?
Sure. Well, I think as our population starts learning and adapting, and it has to be done at the kids' level because they're the ones who are receptive to knowledge. They'll understand that their own health depends on the soil health, and it's not just that. It's to be sustainable. The terms, these are generic terms. You and I talked about regenerative is kind of a somewhat new term. Before, we called it organic. Organic was a federal classification, actually, but or could be biodynamics, or it could be, there was permaculture. There's a bunch of different forms of farming. Clive Edwards called them all alternative. They're alternative to commercial farming, industrial farming. But what's really amazing is that now with the ability to be able to teach this, that these kids who are not even in a rural area or in a farm area can understand the importance. Ideally, I think, and you're right, farmers are hurting, but part of it is because as a population, we're not appreciating how important this good food is. The term sustainability also is a generic term, good term, but it means a lot of different things to a lot of people. Sure. Sustainability means profitability to me. It means less waste. If you got a system that's wasteful, it's not sustainable.
Right.
And sustainable means kind of perpetuate. It's like the term. I mess it up, but the idea that you can keep it going longer and longer and longer because nature is helping as you're growing, right?
Yep.
So you're not fighting Mother Nature. And interesting enough, we see regenerative ranching operations, which is, rotation of animal herds, and you're not cutting the grass anymore. You're allowing it to grow and the biology to stay in it. But what we're talking about is kind of a nice bridge between an industrial system and a regenerative system, because we are still putting inputs into the soil in the attempt of getting a farm started in a regenerative process. So we're amending soils that are not in the best shape, perhaps, and this is a great way to do it, right? So that, to me, that's the cool part is that once you get the system to be regenerative, regenerative simply means humans don't have to have tremendous amount of input. We're not putting in, fertilizers and pesticides and that kind of thing. But we're still at that point where you're using organic, healthy products that have biology and life that are ultimately changing the soil as well. And part of soil health is the amount of carbon we have in it. In Arizona and in the West, we have sandy soils, so that leaches out. Here, you probably have more clay soils in this area. So they can all be treated using a process, and your machinery is helping us do it. So let's talk about the machines you focused on for right now. You've got the extractor for schools and for farms as well. You have
all scales, all scales.
Yeah, and you have the vermicompost bin. What other products is that more or less the product line for now, and where do you see it going forward? What products do you see in the marketplace that might be missing that you guys might get into?
Yeah, so bigger picture, we want to equip farmers with the ability to make their soils healthier.
Mm-hmm.
So that's really our mission. We've landed in the whole idea of vermicomposting and producing extracts as a really good tool to get there.
Absolutely.
There could be other things that emerge, and again, this is based on the work that Dr. Elaine Ingham, Dr. David Johnson, others figured this stuff out. Figured out that you can build your own soil biology inoculations from different composting methods, and then we have a lot of scientific data that demonstrates that the very microbes that plants want to have around them in the soil can be found in worm castings, or other forms of composting like this.
Right.
So you can identify, we have, access to data that shows a number of different worm casting samples from different vermicomposting operations displayed really very similar, this is looking at the bacteria specifically, very similar bacterial profiles, and then identifying what those strains of bacteria are doing, whether it's fixing nitrogen or solubilizing phosphorus, all these different things that, there's a synthetic treatment for, but there's also a microbe for. Get those microbes in the ground, you can start to eliminate some of those synthetic inputs. So that's kind of where we're focused now. And then so building out the system of how do you do that and how do you know you're doing that? We have one size of vermicomposting system really is one way that anyone, I run one myself. I visit my worms twice a week. It's very low maintenance.
Right.
And you can produce a decent volume of castings over the course of a year. So maybe we'll look at other composting methods, down the road to where you can propagate those microbes.
Right.
In a composting environment, they translate very well to the soil. You've got a very diverse profile of microbes that you're inoculating. So instead of going to a lab and propagating this bacteria, dumping them all together, you've got them all in one shot.
Sure. And there's companies out there that sell inoculants.
Sure.
I'm always suspect of, because you've got a lot of diversity and a lot of complexity in any particular soil or any biome. So what you have in your soil here, some of it is the same, but it could be very different profile than we have in Arizona or that we have in Africa.
Yep.
Right. So what I like is the equipment that you have is modular and portable, shippable, and it allows us to then take waste. Basically what we're talking about is waste products, right? So leaves, you got leaves coming down now, the time of the year. You've got food scraps. You've got, if you're running dairy or if you're running any kind of animal husbandry, it depends on what you're blending to create your initial compost. But that product, if it's coming from a local area, chances are that microbial family is paired closely to what we have here. So problem I have with inoculants is I might get something that, it's healthy and everything else, but ultimately it changes so much in the soil. If we take a test at the beginning of the day and the end of the day, it's usually different, right? One family of microbes is eating the next, and depending on the food source or what it's eating, you see an expansion or a retraction of any particular family. Sometimes those inoculants just get overwhelmed with what's in the soil. So the beautiful thing for me on the equipment is it allows me to take it anywhere. And if I'm using local, we talk about local, why it's important. And that's really the reason that we're trying to get this microbiology that's in your soil to be active again. And for many reasons, humans, we've cut everything down. We cut the grass. We have farmed and over-farmed an area. We've got industrial in some areas. And so a lot of those microbes are still there. They're very dormant. The idea is to bring them back or to regenerate them. And your equipment allows you to do that on a local basis, which is great. So you're not buying something from or a product. The other thing is if I want to do liquids, which we know is phenomenal, a great way to drench or inoculate, it's too cost prohibitive, and the shelf life isn't that great. I can't just buy a liquid in Colorado and ship it and then try to use it here. So this really gives us that kind of that missing link, like I said, that we really didn't have. Sure, I can compost anywhere, and I can make a compost tea anywhere, but this extraction device really allows us to immediately get to the farm. So, I mean, it was a thing of, who came up with that idea, by the way? Set
For what?
For the extractors, the extractor series. Is that a team effort?
You mean within our team?
Yeah, within your team.
Yeah. Everything that we sell, we've designed ourselves. So we have a team that, product development and design, they focus on that.
Right.
We work with different farmers in the field to go out and get them tested, make sure that they make sense and on a farm scale in that kind of environment.
And what's the feedback you're getting from farmers at this point in time? People are finding that it's working?
Yeah, I mean, so we can design the equipment. We don't really want to be in a position of telling farmers exactly what they need to do to, produce or source their compost, the application levels. We kind of depend on, and really the people that are doing this right now are kind of your classic early adopters where they're willing to experiment, they're willing to try new things. Mm-hmm. And then as we hear from some of those farmers, we're able to tell, the next generation of farmers, hey, these guys have gotten good results doing it this way. You could start by emulating them and then figure out your own. By and large, really, really good results. Again, not just from using our equipment, but by actually making your soils healthy by inoculating them with the microbes. So a lot of what you hear back is anecdotal. My plants stayed greener longer. The first thing you can observe very quickly is root development, or even before that, seed germination, because again, these are the roles that the microbes are performing. So, you can tell at a glance way better germination rates of your seeds. Mm-hmm. When you go to plant them or after you plant them, the root development is way, significantly higher than it would be otherwise. And then, your plants get healthier, stay healthier. We've heard people drastically reducing to almost zero, or in cases zero, the pesticides that they're using, right, because the healthier plant can resist the pests and diseases that are out in the environment. Yield numbers very comparable to, of course, you're using your synthetic inputs to jack the yield level up to where you want it to be.
Right. Which only lasts so long because you become more and more dependent on the drug, right?
And even within a few years, and this is why it's exciting to me to be able to bring a solution that where you don't have to buy into like the dogmas you were talking about before. You don't have to be certified organic. You don't have to be biodynamic. You don't have to be, regenerative as a label. You can be a conventional farmer, but you just want to stop using pesticides because everyone in your family is getting cancer. You care about your kids. We've heard that story, dozens of times. You want to be able to reduce your pesticides. You want to be able to reduce your fertilizer costs.
Right.
You want more resilient soil. You want the rain that falls to infiltrate into your soil and stay there, not run off and take half your topsoil with it.
Right.
So these real solutions they're not just because you want to save the environment or even because you want to grow healthier food, because unfortunately farmers aren't at this point
focus on it.
They don't get enough of financial incentive.
Right.
Even if they're growing more nutrient dense food.
Right.
Hopefully that changes, but that's kind of where we're at right now. But it's solving a lot of these operational problems and financial issues.
And we're
as well.
seeing in orchards and vineyards, and you're doing more row cropping here. But
So far, yes.
we're really seeing dramatic results. We talked about that the difference if you have a healthy soil and your orchard can last twice as long, or you have less mortality. Those inputs are critical to the survival of the farmer and the financial plan of the farmer. And the end product being more quality, ultimately, when we talk quality, it's the taste, but it's also the amount of yield that you might get, which is a little harder to measure because there's so many inputs in a crop cycle. But I think the cool part about a liquid extract is that it's so cost effective that you can do it at a commercial scale. You can still be an industrial farmer and do it at a commercial scale. It's harder for us to put dry compost down, although I think initially when you're working with a field, as long as you're not over-tilling it too much, the compost becomes the feed, and then this becomes this inoculant or this extract, I should say, starts generating that biology. So what we found, though, is that you're using so much less compost to create that liquid, and that liquid can be done twice during the cycle of a growth cycle for a tree or a grape or for a lot of the crops that we're dealing with in a really cost-effective manner. So it's not that difficult, and the cost of the equipment's pretty low. Most of the farmers already have spreaders, and they have sprayers, and they have labor at certain times of the year that they can that they're not fully utilizing, that they can actually deploy this, and for really small dollar amount. It was surprisingly small.
Yeah.
And I think the benefits are worth it. So I agree with you. I think that it's probably better not to fall with any particular label and just say, what we're doing is going to grow you a better crop, and it's going to grow you better soil, right? So that's part of it. So, yeah, we're really looking forward to the relationship for the schools and for our soil company, Soil, Seed, and Water, starting to use some of this equipment.
Yeah, and we're looking forward to the feedback loop, as you were alluding to. I think largely, again, from the work of people like Dr. David Johnson, we've seen more row crop growers are kind of the first ones to step into this. And, Dr. Johnson did a lot of research before he kind of brought it out. And then there were, those early adopters took his recommendations, applied it in their operations, saw good results, refined them, shared their stories.
Right.
To where we're fairly comfortable talking with a row crop grower and kind of, we know what they can expect by implementing extracts even within the first year. And there's also other resources we can point them to.
That's great.
And other examples. There's a lot less of that so far that we've seen in your orchard, permanent crop setting. So again, it's going to take the first few people, which there are, the first few people are, especially in vineyards, putting it into practice, but then, sharing the stories, the next people come along, maybe scale it up a little bit or refine the operational aspect of it.
Thank you for joining the Harvesting Wisdom podcast. Click subscribe and like for ongoing insightful conversations. Explore our webpage for show notes and additional resources. Visit our guests' webpage for deeper insights. Your engagement is the foundation of our journey, and until next time, keep pursuing wisdom.